Hi, let's go to another LeetCode problem. Today we are looking at problem 347. Top K frequent elements. Given an integer array nums, an integer k, sorry, give me 1 second. Return the k most frequent elements. You may return the answer in any order. So let's look at some. Here I'm gonna assume that I come up with the example there. So, but the output I will think of it on my own. So let's say we have nums. Question. Example nums is 1, 1, 1, 2, 2, 3, and then the k is 2. So we are gonna return 2 and 3. Oh, sorry, what's wrong? So the k most frequent element is the top 2 most frequent. So in here we have 1, that is 3 of 1, 2, that is 2 of them, 3, there's just 1 of them. So we will return 1 and 2. Now example 2, we have nums is 1, k is 1, then we return 1. Alright, I think I will read the problem description, and I have a question. May I ask a few clarifying questions? Can I assume that there will be at least k most frequent elements given in the nums? So let's look at the constant there. So nums length is from 1 to 10 to the power of 5. Nums I is from minus 10 to the power of 4 to 10 to the power of 4. K is in the range 1, the number of unique elements in the array. Right, so that answers my clarifying questions. It is guaranteed that the answer is unique. Follow up. Right, so I should have asked that as well. So let me write down in my notes. Clarify 1. K and only k most frequent element. Follow up. Algorithm's complexity must be better than O n log n, where n is the array size. I think I understand the problem now. I can think of one way off the top of my head to solve this. Because we just want to get the count, then we can use a dictionary to store the count. So first of all, we want to go through for all nums. Then we just use a dictionary to count, then plus 1, and then now we need the k most frequent. Why? So how do we get the k most frequent? And log n. Okay, I got an idea. I think we can use a heap sort here. Heap sort here with k elements. So in this heap sort, we just store the k largest value. Yeah, the top k frequency. Right. Then create heap queue of k elements. And then at the end, we just return all the k, the numbers in k. So I think that would bring us to O of n log k, where k is, so this one is O n log k, and we know that k is the number of unit element in the array at most, which is 20,000, and that is less than the nums itself. So we just assume that all the nums elements are unique, but then it's limited to 20,000 numbers. So that would be faster than n log n. I would like to explore further optimization here. So I'm thinking that if we use a fix, I think we can do better than O and log n. So in the first step that I mentioned, this is the O and log n log k time. And then the space should be O n Yeah, O and space. Now for the second part here, there is another option. I'm thinking that because the nums length is limited to 10 to the power of 5, we can create buckets of size 10 to the power of 5. And then there is something called bucket sort. So it's kind of a similar idea. So in the bucket, we store the nums that have that particular frequency, meaning that we are gonna create a frequency of size nums length. And then we will look through all the count that we have. No, actually, I need to initialize it to an M3 until this. Right. Then I'm going to go through for nums, frequency in count. Then I'm gonna append the nums to the frequency table. So frequency of f dot append the nums. Then I'm going to go through the frequency table and here I'm gonna do it in the reverse way, so 10 to the power of 5 up to 1. Or I can just use the length. So length down to 1. And then I will find out the minimum number, the k most frequent one. Because in this case I have sorted it down to 10 to the power of 5. I'm looping from the 10 to the power of 5 up down to 0, I should say 0. Meaning that whenever I encounter a positive frequency, then that is one of my top k most frequent element. So I do it until I found k of them. Then get k most frequent element. Right. So the complexity here has improved by length of nums, which is let's just say it's n. Yeah, so it's a bit O and time, but then the space here has increased to n plus k, I think. Yeah. But then k is so small that it is negligible, so it's just a O n there. Alright. Wait a minute. Is complexity of addition can be ignored there? Yeah, because O n, the n dominate the k, so it's just O n. Does this sound reasonable to you? I'm thinking that the second approach is much better because do you guys think because I would like to go for the second approach here because it has slight advantage in the time complexity. Does it sound reasonable to you? Should I explore further optimizations? Okay. Alright, let me quickly go through the code to make sure I haven't missed anything. So in the first example, we have nums of 1, 1, 1, 2, 2, 3, and k is 2. We are going to create the count of 1, 1, 2, and then 3, 2 is 1, 2, 3 is 1. Then we construct the frequency table. Frequency. So the length here is 1, 2, 3, 4, 5, 6, 6 elements. So at most there will be the highest frequency will be 6, right? So initially there is, we see that there is 1. The frequency 3, there is 1. Frequency 2, there is 2. Frequency 1, there is 3. And then we are going to loop through from the end up until we find k elements, so 1 and 2. So that's correct. The second problem is 1, k is 1. Now the count of 1 is 1. The frequency of 1, no, 0, 1. Actually, I don't need the frequency 0 because it will be empty anyway. But yeah, it doesn't hurt. There is 1 here, so we got that. So let's think through some more edge cases. So nums length 1 we have explored, so that is covered. And how about the nums is negative? Does it matter? No, it doesn't matter. Yeah, I think it should work. Okay, I would like to start implementing this. Shall I proceed with coding? Thank you. Right, actually, I should. Actually, I'm not sure I should have go through the example here. So let me just check whether I should do it before or after. I see. So I think the best way in coding interview is that you go through the test cases before and after. So this is to verify that your code does work. Okay, so I think we can go through the implementation now. Right. So I'm gonna use first of all, gonna import default tick, so it makes life easier. So count is a default tick that stores integers. Then I'm going to go to all the elements and then I check the count of it. So I'm counting the frequency. And then, so that's the count of its number. How about the frequency? Now let me think if I can. I'm thinking about whether there is a better variable name here for frequency. So we are mapping the frequency to the number. So this is returning the number given a frequency. So I'm just going to call it bucket here. Oh, better one is setting frequency bucket. Right? So I'm going to initialize all the elements to see to an empty list. E in range. Yeah. Now I will go to the count. One num count in. Let's call it right here. Count the items. Then I append the number to the frequency bucket. Yep, looks good so far. Now I'm going to retrieve the top k element. So top k equals 0. Then I'm going to look to the frequency bucket for I in range length of nums -1 to -1 -1. Okay, I think I got an idea how to do this. In syntactically, syntactic magic here. So top k, sorry, top k dot extend frequency bucket of I, and then I'm gonna check if there we have one k element. Then we will return top k. I think this will work. So let's quickly go through our example again. Alright, let me quickly walk through the code to make sure I haven't missed anything. First of all, I create the count, and then I count its number, the frequency of it, store it into the count dictionary. Then I create a frequency bucket of size length of nums. Then for each item in count, I'm gonna put the num into the corresponding frequency bucket. At the end, I will have this top k, and I'm going to look through the list of frequency bucket from the end. So I'm taking the largest frequency first. So I keep on extending it using the frequency bucket. I add all the nums, and then once I reach k element, I return it. I think this will work. Now let me test the code with the test cases. Yeah, so count 1, control count 3, we have 3, 2, 1 frequency bucket. We have frequency, then we append 3, 2, 1, 3, 1, 2, 3, and then we go to the end, it's empty, 5, 4, 3, there's 1 now. Okay. One, and then 2. Then in the second example, there is only 1, then we return it. Okay, I think that's will work. So let me quickly input our solutions here. Solutions import the public count equals to public integer num in nums count of one the frequency bucket. number in range of length of nums minus 1 minus 1 minus 1 k dot extend okay, this will be the frequency. Frequency packet frequency. Right. Then if top k then top k equals k top k. Okay. What happened here? What is wrong here? Oh, right. Okay, so I'm missing one. Okay, got it. Yeah, so the second one is not successful. Right. So this one is not right. Yep. I think this should work. So let's then yeah, runtime 50. Using a counter, I haven't heard of any counter in Python. There, okay, so there is a counter. Interesting. Okay. It's not a standard library, so I'm gonna ignore that. But here it is using a heap queue. Well, of course, if I can use a sorted dictionary pattern, then it will be faster. Hmm. I don't understand why my complexity is higher than other people. I think it's just some variability. Should be fine. So the node I can, uh, instead of creating a frequency bucket of size length of nums, I can just create a dictionary for that. But then it also means that I also need uh, to sort the k elements. The k, uh, I need to get the top k elements, so I need to go to k and then find out the k elements. K most frequent. So that will be a O of number of unit number times log k. So that might be a bit faster and it saves our memory. Yeah, I think that's just some further exploration here. So let's stop here for this problem. Thank you.